we solve linear systems using graphs. Let's see where the lines intersect. Then we learned how to use substitution to do it, and then we're going to use another method called elimination here. And I'm going to break this down into two separate parts to get us a little more practice. Essentially, this is another version of substitution. You just sort of makes it a little bit shorter. You sort of consolidate some steps here. So again, we're still talking about REI 6 here. Again, we'll do this one, and then we'll do another part, and then that'll wrap up our time with that one. All right, so let's go ahead here. All right, so in previous examples, what we did on these kind of things is we took it and we would solve, we'd either graph it, right, which you could do for either one of these, although both of these look like they would be sort of irritating to graph since these are both in standard form, although this one is, A is negative here, but 11 is not divisible by 3, nor is it divisible by 2, so my intercepts here wouldn't be very nice. It'd be a fraction. So just overall, I think this one would be a little bit annoying to do. Same with this one. If we try to do substitution, right? If I solve for 2x, or solve for x, or I solve for y, it just is going to. I'm going to include some fractions there, and it's just going to not work very well, frankly. So let's go ahead and we're going to do this idea of elimination. And so elimination says I'm going to rewrite my equations here. So 2x plus 3y is equal to 11, and then I'm going to do negative 2x plus 5y is equal to 13. And essentially what I'm going to do is I'm going to add my two equations together. Okay, since the variables are the same, x and y mean the same thing, I'm going to go ahead and add these things together. And the goal here is to eliminate one of the variables when I'm adding them together. So here I have a positive 2x and a negative 2x. And realistically what happens here is if I add these together, I'm going to end up with 0. So I'm going to add these two equations together. So 2x and negative 2x, that's going to be equal to 0. Okay, these will cancel out. And I'm going to put a little positive here just to remind myself that a positive and a negative of the same amount need to cancel out to be 0. Well, then if I have a positive 3 and a positive 5, I'm going to end up with positive 8. And if I add 11 and 13, I'm going to get 24. Well, then 8y is going to be equal to 3 after I divide both sides. And now I can go ahead and solve for x. And I'm going to use that first equation here. So I'm going to do 2x plus 3 times 3 is equal to 11. So I get 2x plus 9 is equal to 11, and 2x is going to be equal to 2, so x is equal to 1. So I have 1 comma 3. Okay. And if I plug this back into the other equation, right? So if I do 2 times 1 is 2, 3 times 3 is 9, 2 plus 3 is 11. That should make sense. That's the one we just did. And then let's check here too. Negative 2 times 1 is negative 2. 5 times 3 is 15. Negative 2 and 15 makes 13. They check out. If I were to graph this, you would find that both of these lines would intersect at 1 comma 3. So, and in fact, let's go ahead and let's graph it real quick. So I've gone ahead and I've set up these equations, both 2x plus 3y is 11 and negative 2x, and I put this into Desmos, and I'm just going to go ahead and we'll highlight this and graph it. So this would be 2x plus 3y is equal to 11, okay, if I were to graph that one. And then if I graph negative 2x plus 5y, we'll notice that the intersect at, whoa, did I enter them in wrong? What was the, oh yeah. This one was 13, so that might help. Nope. As I try to fix this, there we go. 1 comma 3. Okay, and that's where they intersect. All right, so back to our equations. So let's go ahead and let's try another one here. Okay, 4x plus 3y is equal to 2, and then I have 5x plus 3y is equal to negative 2. Now, if you notice, if I were to just straight add these, right, I notice 3y and 3y, those are the same value, but these are both positive. So this isn't going to quite work for just adding them. Okay, now some of those techniques you'll see they'll teach you to subtract the two equations. I would encourage you to sort of avoid that, and what I like to do instead is I like to just turn one of them into, like multiply it by -1 so I can still add. So what I'm going to do here is let's take I'm going to make the one with the smaller x, right? I'm going to make that negative. So we'll do negative 4x. And then, so what I'm doing here is I'm going to multiply everything here. I'm going to multiply it by negative 1. Okay? So I'm going to get negative 4x minus 3y is equal to negative 2. Okay. Now you're just asking me maybe why did you multiply by negative 1? I'm going to do that because if I rewrite the second equation here, you'll notice these will now cancel out if I add, okay? If I were to subtract, sometimes you start subtracting, you subtract negatives, and it gets a little bit convoluted, a little more complicated than I want it. So I'm going to remove that potential error there, and I'm going to just multiply everything by negative 1, basically make everything the opposite here. And now I'm going to add them together, okay? And now, hopefully what's going to come clear is why I chose the one with the smaller x value, because when I make that one the opposite, then when I add these together, I'm going to end up with a positive value, right? This negative 3 and positive 3 cancel out, and I'm going to end up with x is equal to, add those, negative 4, okay? If I had made, this equation negative, then I would end up with a negative x, and it's just one extra step that if we plan for it, we can avoid it, okay? All right, so then let's go ahead and we're going to plug this equation, plug it back in. I'll use my very first equation there. 4 times x plus 3y is equal to 2. Okay, so 4 times negative 4 is negative 16 plus 3y is equal to 2. So 3y is going to be equal to 18, and then y is going to be equal to 6. Okay, so I know that we've got negative 4 comma 6. That would be my answer. Well, let's check it. Okay, so negative 4 times 4, negative 16. Negative 16 plus 18, that does equal 2. Let's try it here. 5 times negative 4 is negative 20. 3 times 6 is 18. Negative 20 and 18 is negative 2. So it does work. Okay. And if we wanted to, let's see, we can graph it real quick. Let's see if I can graph it correctly this time. So we'll do 4. Let's see. Go over and type it in real quick. It's, what was it? 4x plus 3y is equal to 2. Plus 3y is equal to 2. Okay, and then our second one was 5x plus 3y is equal to negative 2. Okay, and these intersect at negative 4 comma 6. Negative 4 comma 6, that's what we got. Okay. Why don't you go ahead, pause the video, and you try doing this one together. Okay, so you might have noticed right away that there's something a little bit different about this one, right? This one is in standard form, and this one is not in standard form. Okay, it doesn't actually matter. Let me do this two ways. Okay, the first way is if I actually just added these together, right? This is a negative 4y, and this is a positive 4y. So what I can do is I can say 8x minus 4y is equal to negative 4, and then I get 4y. And what you'll notice here is I lined them up, right? Is equal to 3x plus 14. Now if I add these together, this is a positive 4y, and I'm going to get 8x is equal to 3x, and then negative 4 and 14 is positive 10. Now I'm going to have to subtract 3x from both sides, and I get 5x is equal to 10, so x would be equal to 2. Okay, and then from there I can say 4y is equal to 3 times 2 plus 14, so 4y is going to be equal to 6 plus 14 is 20, so y is equal to 5. So I would get 2 comma 5. Okay. Now another way we could have done this is I could have set it up so that they're both in standard form. Okay, and so what I could have said is I could have said, okay, 8x minus 4y is equal to negative 4. Okay, and then what I'm going to do is I'm going to take this and put it on this side so that I get a negative, right? So then it's negative 3x plus 4y is equal to 14. Okay, and when I add these together, negative 4, positive 4, that makes 0. I get 5x is equal to 10, which is the same step I had here, right? So notice the minus 3x, okay, here I did it after I put the equations together, and in this step I did it before I put them together, okay? Typically, I think this way, if you set it up so that your x's and y's and everything lines up, I think typically leads to less errors, but it's entirely up to you. If you feel comfortable doing it either way, go for it. Okay. If you find yourself making mistakes, then try maybe a different system. Okay. All right. So hopefully you got 2,5 there. Let's go ahead and do one more here. Why don't you go ahead, pause the video, and you try this one. All right, hopefully an opportunity. I'm going to do it like I said before. I like to put the x's and the y's on the same side, so we're going to leave this one as 2x plus 5y is equal to 12, and this one I'm going to change so that it becomes negative 4x plus 5y is equal to 6. Okay. This x, right, the positive 5, one of these I have to convert to make negative, right, to make, oh, if I could talk, one of them I need to change to negative. So this is the lower x, so I'm going to change this one. So I'm going to have 2x plus 5y is equal to 12, right, and I'm going to take this one and multiply the whole thing by negative 1. So I get 4x minus 5y is equal to negative 6. I'm going to add them together. I get 6x is equal to 6, which means x is equal to 1. Let's plug it in. We'll just do it that first one. So I got 2 times 1 plus 5y is equal to 12. So 2 plus 5y is equal to 12. 5y is equal to 10. Y must be equal to 2. Okay, let's check it. So we're saying 1 comma 2 is the solution for both of them. Okay, 2 times 1 plus 5 times 2. 2 times 1 is 2. 5 times 2 is 10. That equals 12. Let's go here. We need, let's see, 4 times 1 is 4, plus 6 is 10. 5 times 2 is 10. That works as well. And there we have it. Okay, tomorrow we'll do some more practice like this, and then there'll be a second part to this video which adds another level of sort of complexity, but nothing you guys can't handle. So, okay, see you tomorrow.